Hello, this is the AP Calculus PC 2019 problem number 11. We need to evaluate the integral from 0 to pi of e to the x minus 1 over e to the x minus x dx. So the way that you're probably taught this in school is using u substitution. And that's actually the way I'm going to show you first. So we notice that the derivative of this is this. So I'm going to say u equals e to the x minus x. Du equal, then we would say du over dx equals e to the x minus 1. And that means dx equals du over e to the x minus 1. So now we just need to change our limits. So when x equals 0, u is going to be e to the 0 minus 0, which equals 1, because e to the 0 is 1, 1 minus 0 is 1. And now when x equals pi, u is going to be e to the pi minus pi. And we're just going to leave it like that. So now we need to substitute e to the x minus x and, for our u and plug in our limits of integration. So we're going to have the integral from 1 to e to the pi minus pi of 1 over our x and then times du. Okay, and since our u corresponds to this, and our dx corresponds to that. So now we're going to evaluate this integral. That's going to be ln of u, evaluated from 1 to e to the pi minus pi. And now that is going to be ln e to the pi minus pi minus ln of 1. And that is ln of e to the pi minus pi. And now e to the something equals 1, that'd be 0. So our final answer would be ln of e to the pi minus pi. Now, there's a second way of doing this. It's very similar, but it takes a lot less steps. I'm going to rewrite the integral down here. Not minus pi, minus x. Dx. So again, we can see that the derivative of this is this. So instead of substituting it in for u and everything, I'm just going to say it's 1 over e to the x minus x times the derivative of e to the x minus x. Because we can see 1 over e to the x minus x times the derivative of this. Well, the derivative of this is just this over here in the numerator. So it's going to actually be the same exact integral. So now we can treat this as a 1 over u. Since we already have the integral of that, we don't need to worry about the chain rule or anything of the like. So it's going to be ln of e to the x minus x evaluated from 0 to pi, which is exactly what we got over here. I'm just going to say that ln of e to the pi minus pi minus ln of 0, and that equals 1. And so those are two different ways to do it. Again, the second one is quite faster, as you can see. But thank you much for watching, and goodbye.